Then the next step would be to estimate the ductwork, right? Estimate the quality and cost of the air ducts associated with air handling unit 1. And I do want to do that exercise because the issue is that when we have the ducts, from the plan layout, we can only measure linear feet, right? But we know that duct is going to be a rectangular type or circular type, depends on what the application is. So we need to estimate these areas and then convert that into weight, because the cost is usually given in weight. Let's see, I have here the RS means for HVAC equipment, see, and then it says the rectangular duct is taken off by the linear foot for each size, but its cost is usually estimated by the pound. So that's why we need to do that conversion. And okay, so this table gives us the weight of the duct depending on the size. So basically we have these two dimensions they call W and L, right? So we want to add W plus L, and then the table considers that that's times 2, right? Because the perimeter is 2 times this width plus 2 times this height, and then if we multiply by the length of the duct, this perimeter times the length will give us the surface area, right? So what they have done is they say, okay, if we take 1 foot of duct, okay, I need to know the perimeter, and I multiply by 1 foot, and then I get this surface area in square feet. So you add these two dimensions, that gives you the square feet per foot of linear duct, and then depending on the gauge that you have, it gives you the weight per foot in pounds. Okay, so it says here weight per pound. Let me put it up a little bit. Yeah. So here we have duct weight per pound depending on the gauge. Okay, we have weight per foot and weight per 5 feet. So this would be 5 times the weight per foot. I don't know why they put it in there like that way. Is that clear? So we have the surface area and then the weight. And we can use that data to estimate the cost of the ducts, because we can see in this RS means table the cost for rectangular metal ducts in galvanized steel is cost per pound. So we need to have the pounds in order to get the cost. Is that clear? Okay. So we go here to on-screen takeoff, and basically what I'm going to do is I'm going to take this area and send it to a hide layer so I can work on a clean drawing. And then I'm going to start looking at the ducts for air handling unit 1. So I see that the air handling unit 1 starts with this piece 16 by 12. So I'm going to use that as an example, right? So I'm going to create a new linear condition, This would be a 16 by 12 rectangular duct. Okay. The thickness of these will be 16. And basically I just measured this section. Now, one thing to take into consideration, when the architect draws here and says this is 16 by 12, it means that the width of this duct is 16 inches. And that is the dimension that you can measure right here in the drawing, okay? And the height, which is perpendicular to the drawing, is 12 inches. So this is 16 by 12. Okay? Now, if we had a cross-section here, and we look at this duct from the side, the duct will look like this, right? And the dimension that we could measure is 12. Yes? So the architect will write 12 by 16. Okay? The first number is the one that you can measure in that drawing. And the second one is the perpendicular. It's the same duct, but it's looked from two different perspectives. The first time we look from the top, so we can read the 16. So I will say 16 by 12. The second case, we're looking from the side, so we can measure the 12. It will read 12 by 16. Okay? Just for your reference. Okay, so we have this 16 by 12 duct, right? If we go to our takeoff, here is 16 by 12 rectangular duct, and this is a 4 feet long duct, right? So I can go to my on-screen takeoff area, and then just basically, you know, copy this and paste it into Excel, right? So I have the rectangular duct. So I'm going to use the calculations here to calculate the duct weight, right? So basically, I'm going to copy. I'm just going to be a little lazy about that. The 16 by 12 duct. The linear feet is going to be 4 linear feet that I took off, right? And then I need to find these dimensions. Where is my my blackboard? Okay. So I need the slide that helps me to calculate the duct weight asked for L plus W, right? So how much is L and how much is W? I need L and W. How much is L and how much is W?
16.
Yes. And 12. Right? So L plus W is going to be the sum of these two. 28. Right? So now I will go here to this table and I will find W plus L 28. Is this one here. So it says that I have 4.92 square feet per foot. Right? 4.92. So I can write here square feet per linear feet. .92, and then I have pounds per linear foot. What gauge are we going to use? When in doubt, I'll go for the middle one. right? So I'll use 22 gauge. For 28, that means we have a 6.92 pounds per linear feet, right? 692. So the weight is 6.92 multiplied by the linear feet that I have. So that section of duct is 27 pounds weight. The weight of this section is 27 pounds. It seems kind of heavy.
Go back to your calculations. And then, which cost reference is that?
Well, I haven't used the cost yet. I haven't calculated the cost. This is what I have done.
That chart though, which
This is estimating module 4
yeah.
slides. Okay, so this is a slide, I don't remember which one. It's one of the slides that we have on the module, slide number 83, okay, in the module 4 handouts. Okay, the module 4 handouts. Now, there's other ways to get to the same value. We know that the surface area, right, the surface area is going to be the multiplication of the perimeter times the length, right? Surface area is perimeter times the length, right? The perimeter is going to be 16 plus 12 times 2, right? But that's in inches. So we need to divide that by 12 to get it into feet. Yes? So that would be the perimeter. If we multiply the perimeter by the length is going to be in feet. So then the surface area is going to be in square feet. The multiplication of the perimeter times the length. So if we would like to do that, we can do that calculation, you know, in Excel. We can have again, you know, it's going to be confusing if I put it in here again. So let me just create another one. I'm going to create another sheet here. What I'm going to do is I'm going to do the calculations by hand rather than you know, than using the table, so I know if it is correct or not. The perimeter in feet is going to be the length plus the width, right? Multiplied by 2 divided by 12. So the perimeter is 4.66. The surface area is then going to be the perimeter times the length. So I have 18 square feet here. The calculations I did before, I didn't calculate the, I calculated the square feet per linear foot. That's 4.92, which is close to this one. I have 4.67, table says 4.92. They probably add a little factor over there. The factor is, well, I don't know, that seems a little high. The factor is because you have a sheet of metal, right? You have a sheet of metal, and then to create the duct, what they do on site is they start bending this thing, right? So they create the metal duct like this. And then at the end, they bend these two, and then they close it. So they take the two last section like this, and then they bend it together to create the seam of that duct. So I'm thinking the difference may be because of that, but it seems a little high. Anyway, you will have you can calculate the cross area by doing that. You calculate 2 times the length plus the width divided by 12, multiplied by the length, that gives you the surface area. And then if you have the weight per square feet, then you can calculate the total weight. And I think I have there's a table where I have this section. So in any event, this is what we wanted to do. We wanted to calculate the weight of this duct, right? So now in our table, we have a cost for the ducts. So the cost for the ducts is here. We have rectangular metal ducts. We'll use galvanized steel under 2,000 pounds. The cost is 47 cents for materials and 4.68 installation, right? So this will be galvanized steel duct up to 200 pounds. The cost is per pound, and then we have that cost is 0.47 468. And the quantity we have here in the calculations this way, right? So right now, yeah, it doesn't seem much, $142, but we only have calculated one small section, right? So what we would need to do now is to keep going here. We have a 14 by 12. So we'll create a new condition. This will be a linear condition. And now it will be 14 by 12. Rectangular duct, right? So the thickness here will be 14, and then we'll go here and keep going. Now you will say, okay, how about these transitions, right? The transition, it's a small section that goes from 16 inches wide to 14 length. So what they do is they form that on site. So what you would do is go, with the larger diameter and just cover that section with the larger diameter. That's the easy way to do it. And then we'll have another linear condition. This one will be 12 by 10. Rectangular duct. This will be 12 inches wide. And then we go here. Okay. So when we go to the takeoff, now we have these 16 by 12, 14 by 12, and 12 by 10. So basically what I need to do now is copy that. Actually, I'm going to copy all three again because I want to update these here. So we have these 14 and 12. In my calculations, now I have 14 by 12, so this is 14, this is 12, this is 12, this is 10. L plus W is now 26 and 22. So I need to go to these tables and look at 26. 26, we have square feet per foot, that's 4.58. And pounds per foot, $6.44. So the weight is going to be 167. This one is L plus W 22. So 22 is 3.79. And the weight of 22 is 5.33. So now I can calculate total weight, right? The total weight here would be the sum of these three sections. So now it's easy because I have the RS means table. I have the cost per pound, right? So all I have to do is update the weight to the sum of these three sections. And now my cost goes up to 1,300. So in this weight, I have the weight of the three sections that I have taken off in calculation. So I have the 16 by 12 rectangular duct, the 14 by 12 rectangular duct, and the 12 by 10 rectangular duct. Any questions?
Can I see the formula you used to calculate the weight?
The formula that I use to calculate the weight,
Yeah, for each one of them.
think about it and tell me the formula. What would be the weight? The weight per linear feet multiplied by the linear feet that you have, right? So if we look at this, we have the weight per linear foot is 6.92, and the linear feet that we calculated is 5. So the weight should be 6.92 times 5, which is this cell, the weight per linear foot multiplied by the linear feet that I have on that section. Same is true for the other one, right? The next one is going to be now 6.44 times 26 linear feet. The next one is going to be 379 times 10.
Does it matter if you add, if it becomes 5 or if the other one becomes 27?
I'm sorry, I didn't catch that. What was that again?
You know, I had the way you add the little area that was.
Oh, okay, yeah.
Does it matter if it's on the 27 instead of 5?
Well, see, the problem is that you're going from a larger section to a smaller, right?
Oh, okay.
So if you take the smaller one and pull it back, you're going to be short on material. If you take the larger one and pull it forward, you're going to have more material than what you need. So it's normally safer to go on the larger side. I mean, it's a small section anyway, so it doesn't really matter too much, but you keep doing that consistently, and then all of a sudden you're going to be underestimating the materials.